Recall the problem that we were working on. We had some code to make a square of squares. Here's the code, actually. We decided that we'd have nested loops, an outer loop based on an I control variable and an inner loop based on a J control variable, just like the gears we were looking at. On the inner loop, each time we went through the inner loop, we printed a single square, and that inner loop caused us to make, say, 4 squares if n was 4, and then that was our smaller gear. The outer gear, the outer loop, would be go through that inner loop n times. In this case, do 4 rows of 4 squares. So I wanted to just quickly go through a full trace of this program. Many students many students find that this helps. Okay, so let's do it. All right, so in a situation where we have nested loops, when tracing, we need to keep track of both the I variable and the J variable. I will start as 1, and while I is 1, we go into the inner loop and we set the J variable to 1. Now keep in mind the I variable will be stuck at 1. We will not execute the I++ until all the contents of the loop have executed. In this case, the contents of the loop is itself a loop. That whole loop has to finish executing before we're finished with the contents of the outer loop, and that's when the I++ happens. All right, so we start off with I being 1 and J being 1. In that case, we go into the inner loop and we say, okay, 1 is less than or equal to 4, so print a square. Now we go with J++, so J goes to 2. 2 is less than or equal to 4, so we print a second square. We J++ again to 3. 3 is less than or equal to 4. J++, 4 is less than or equal to 4. J++ until we get to 5. That finishes the execution of the inner loop. Okay, without the outer loop, we'd be done, but now this just means that we've finished everything inside the outer loop, and now I++ can execute. So the I, while J is still stuck at 5, now I goes up to 2. Okay, and that's the end of the first iteration of the I loop. Now we begin the second iteration of the I loop, and the first thing we do is check to see if the current value of I2 is less than or equal to n, which is 4. It is, and so we jump in and we execute the J loop again. But now it's a whole new execution of the J loop, so the let J gets 1 executes before we begin. So J was 5 from our previous execution of the loop. Now it's reset to 1. Okay, so at this point, I is 2 and J is 1. J1, right? J's value of 1 is less than or equal to n, which is 4. And so we print a square. J++ from the inner loop. Remember, the outer loop I is still stuck at 2. It will stay stuck at 2. But the inner loop is 1. We do a plus plus and get it up to 2, which is less than or equal to 4, so we print another square. J++, J goes to 3, print a square. 4, print a square, until J++ up to 5, which means the inner loop is done again, which means the second run through of the inner loop is done, which means the outer loop can now execute its I++, and so I goes up to 3, and that means we're going to go 3 is less than or equal to 4, so we go into the loop again, reset I one more time, reset J one more time, so that I is 3 and J is 1. We now go again. 1 is less than or equal to 4, so print the J, J++, print, J++, print, J++, print, J++, J loop is done. Go back to the I loop for an I++, I is now 4, which is still less than or equal to 4, so we do it again. J gets reset to 1. Go into the loop, print a square, plus plus, print a square, plus plus, print a square, plus plus, print a square. Now J goes up to 5. The inner loop is done, which means I++, now I goes up to 5. We go back to the outer loop. 5 is no longer less than or equal to 4, so that ends the execution of the outer loop, which means we don't go into the inner loop another time, and we're done. Okay, and now we have printed all 16 squares.